Okay, let's jump right into this explainer. Today, we're uncovering the secrets of an invisible force that literally surrounds us all. It's kind of like a master shapeshifter, constantly changing forms to make absolutely everything in our universe happen. Yep, I'm talking about energy. To get our brains warmed up, I want you to think about this question for a second. What does a small, simple action, like a book falling off a shelf, have in common with a massive, terrifying force of nature, like a hurricane? It sounds like a trick question, right? Well, the answer is actually the secret to understanding how our world works. They are both powered by the exact same thing: energy changing its form. So, here is our roadmap for today. 1. The shape-shifting energy. 2. Events versus processes. 3. Mapping energy changes. 4. Useful power and destruction. And 5. The candle experiment. All right, moving right along to section 1, the shape-shifting energy. So energy can be stored away, right? It's kind of like keeping a battery in a drawer. But here's the thing. When it's just sitting there stored, it does absolutely nothing. To actually do something useful, it has to change forms. Think about the explosive, crazy movement of bouncing tennis balls. That kinetic energy, that movement, came from a stored source. Or take a cooking pot being heated over a roaring outdoor fire. The wood fueling that fire is literally a store of chemical energy. It's only when you burn it that the chemical energy shapeshifts into thermal energy, or heat, to cook your food. And it's not just roaring fires and bouncing balls either. Even a simple, everyday action like just walking up the stairs is a massive shape-shifting act. You're taking the chemical energy stored in whatever you ate for breakfast, and your body is actively changing it into kinetic energy. Movement. Plus, because that movement is taking you higher up those stairs, you're also building up what we call gravitational potential energy. You are literally a walking, talking energy converter. How cool is that? Which brings us to section 2, events versus processes. As we look at the world around us, we basically categorize these energy shifts in 2 ways. First up, an event. This is something that happens once and has a clear end. Remember that book falling from a shelf we just talked about? That's an event. The book's stored gravitational potential energy changes into kinetic movement energy as it falls, and then it hits the floor. Bang! It's done. A process, on the other hand, is an ongoing transfer. Think back to that cooking pot. The burning wood is continuously changing chemical energy into thermal energy over a long period of time just to keep that fire going. That is a process. All right, section 3, mapping energy changes. Now, scientists love to keep things organized, so they use simple diagrams to track all these changes. Take a massive power station, for example. This place is responsible for one of the absolute most important energy chain reactions on Earth. It uses the chemical energy stored in natural gas to eventually give us the electricity we use to power our everyday lives. But that shift doesn't just happen all at once. It happens in stages. We can actually track this exact process using simple block arrows, turning a super complex real-world facility into an easy-to-read scientific diagram. First, we start with the chemical energy in the natural gas. Then an arrow points to the next step, thermal. The gas is burned to create heat. Another arrow points to kinetic. That thermal energy boils water to make steam, which spins these giant generators. And that spinning is the movement, the kinetic energy. Finally, an arrow points to electrical. The spinning generators shift that kinetic energy right into the electrical energy that flows through the wires and into your home. See? We just mapped out a giant complicated factory using 4 simple words and 3 arrows. Let's move into section 4, useful power and destruction. So while some energy transfers are incredibly helpful and totally necessary for modern life, others, well, they can be terrifying. But let's start with the good stuff. When we harness these shifts deliberately, we get useful energy changes. Take your television, for example. We can map its energy change right now in our heads. Your TV takes electrical energy straight from the wall socket and changes it, draw an arrow in your mind here, into sound and light. That is a highly controlled, incredibly useful energy change that lets you watch your favorite shows or play video games. But let's contrast your TV with the aftermath of a massive storm like a typhoon or a hurricane. Nature transfers unimaginable amounts of energy all the time. When a hurricane hits land, it transfers massive kinetic energy through powerful raging winds. And that energy transfer, it's not helpful, it's heavily damaging. Earthquakes and tsunamis are other real-world examples of sudden, massive energy changes in nature that are highly dangerous. The science is exactly the same as our bouncing tennis ball, just on a much, much larger and scarier scale. And finally, section 5, the candle experiment.
Okay, so we obviously aren't going to build a power plant today. Instead, we're bringing these giant concepts right down to a tabletop level so we can prove the science ourselves. Here is our lab set up to investigate how chemical energy changes into thermal energy. But first, a quick word on safety. Safety glasses are an absolute must. Since we're dealing with an open flame, the candle cannot be knocked over, and all flammable materials have got to be cleared away. If you don't respect the energy transfer happening here, you could get seriously hurt.
So, here is the exact scientific process we're going to follow. Step 1, we measure the starting temperature of the cooking oil in our beaker. Step 2, we light the candle underneath it and immediately start our timer. Step 3, we stir the oil at regular intervals so it heats evenly. Step 4, we record the time and temperature every single minute in a table. And finally, Step 5, we stop the experiment the second the oil's temperature has gone up by exactly 10 degrees Celsius. By doing this, we are literally tracking the energy shift in real time. Now, I have a really critical lab safety question for you. During Step 3, I told you to stir the oil, but explain to me why you should not use a thermometer for stirring. Think about it for a second. Thermometers are made of thin glass designed to be sensitive to heat, right? Not to withstand physical force. If you try to stir with it, it could easily snap, completely ruining your experiment and creating a really dangerous hazard. So always use a proper glass stirring rod.
There's actually something else we need to notice about our experiment. We obviously want the candle's thermal energy to go directly into heating the oil. But in the real world, energy changes are rarely perfect. Actually, a lot of that thermal energy is what we call wasted energy. I mean, think about it. Where else is the heat going? It's heating up the metal tripod, the gauze mat, the glass beaker itself, and even just the air surrounding the flame. So the useful energy goes into the oil, but the wasted energy spreads out everywhere else.
And that brings us to our summary checklist. You should now feel totally confident with these core concepts. You know that stored energy does nothing until it's transferred. You can spot awesome real-world examples of these changes, from digesting your breakfast to a hurricane tearing through a town. And you can draw block and arrow diagrams to map out these complex processes like a true scientist.
To leave you thinking today, I want you to look away from your screen for just a second. Seriously, look around you. If energy is always changing forms to make things happen, what invisible energy shifts are happening right now in the exact room you're sitting in? Is a light bulb changing electrical energy into light? Is a radiator shifting thermal energy into the air? Science isn't just something that happens in the lab. The shape-shifting power of energy is happening everywhere all the time. Keep your eyes open and you'll see it. Thanks for joining me on this explainer and keep questioning the world around you.